That's new this year. On the same plane. We have it over there. It's on our word wall on that side. Coplanar way back from chapter 1. Okay? Everything's on the same plane. And they're two lines that never intersect. So when you parallel park, what are you parking parallel to? The curb. If you hit the curb, do you pass your test? I also hit the curb. That was the only thing I did wrong, though. It's like the only thing you do wrong, you think you can still pass. Did you do a lot wrong?
I did.
That's insane. I did pass my first time. Okay, so we have two coplanar lines that never intersect. So two lines that never touch. They're going next to each other. Now, I didn't write mine perfectly, partly because I'm a human. I know. Very rude. Okay, so. Hi. You too. All right. So as we look at this, even though mine don't look exactly parallel, especially like towards the end here, you can see mine's kind of starting to like go a little crooked. To tell our reader, hey, these are supposed to be parallel, we do these little like triangles. Sometimes we use arrows like this with the arrows. We kind of make another arrow in the middle saying that, hey, these are supposed to be going the same direction. Or we can change it into kind of these triangles. I like the triangles better because I just like coloring and filling in shapes. But either way, we kind of make them arrows or we make them triangles, and that tells our reader, hey, these are both going in the same direction. So take a look around the classroom really quick. Where do you see parallel lines? Yeah, the sides of your desks, right? The left and right side of the desk. Those are never touching. Where else do we have parallel lines? The roof. What part of the roof? The ceiling. Yeah, the lines on the roof. The lines on. Why are you flying at the roof? The ceiling. So if you look over here, where the lights are, these lights are running parallel to each other. They're not intersecting. Pretend they don't do that over there. Okay. So those are parallel. Good. All right, next up we have skew. Skew is really similar. So take a look at that definition of skew. Two non-coplanar lines that never intersect. That is almost the exact same as the other one. What's our difference in our definition?
They're not the same plane.
They're not in the same plane. They're non-coplanar. So the big thing here is that there's going to be space between them. Okay, so if you take a look at these lines that I have written on these handy-dandy Post-it notes, right now, if I do them like this, they're on the same piece of paper. It's like we could tape that piece of paper together, right? Really, right now, they'd be the same line. Oh, right now, they'd be the same line. If I move it like this, then they'd be parallel. Okay, even if I lift this off, as long as they're going the same direction, they're still parallel because I can still connect them and they'd be parallel. So I want to tilt it where it would look like they're going to intersect. Right now they're on the same plane, so they would touch. But if I lift this off the paper, is this line actually intersecting this line? No, because there's space between it, right? But if you look from here to here, where is it? Right here. No, we got it. Right here. Is this line going to touch this line? No, there's space between it. Okay, I'll do that a little bit better. Show you a second. So we have that space. Together they would intersect if they're touching, but because there's a space between it, they're not touching. So if they were on the same plane, they would touch, but since they're different planes, they don't touch. So in this classroom, what would be a line that is skew to this line here that's going this direction? So it needs to be on a different plane, so you can't look at the ceiling. It has to be somewhere else that would be here, not going with this. Okay, but the line on the floor goes the same direction this way. Are you looking at the in-between lines or these lines? Oh, these lines. Yeah, these lines would work really well. This line over here, right here on this wall that goes this way, is this line ever going to touch that line? No, where it looks like they would almost touch, right here, there's still space between them. Okay, so that skew means that there's space between. But they can't be going in the same direction, because even if they don't touch, like, there we go, I got this, I can do this. Lines are hard sometimes. This corner line is vertical, right? In the line in the back there is also vertical, going up and down, connecting those corners. Does this line touch that line?
What line?
No, but since they're going in the same direction, I'm talking about where the corners meet.
Oh.
Sorry, where the corners meet, that vertical line. Okay, but even though they're going in the same direction, they're still parallel. Even though they're not on the same plane, there's not a wall connecting them. So that's kind of our big difference between parallel and skew. Parallel means they're going in the same direction. So parallel should always go in the same direction. Skew means that they're going in different directions. Meaning they would intersect if they were together, but because they're separated, they're never going to touch. So for example, here when you look at line L and line M, they're showing them on two different planes. If we squish those planes together, those would intersect, but because there's space between, they're askew. All right, last one on this top part is parallel planes, and those are two planes that never intersect. So if we take a look at this room, where do we have two planes, two flat surfaces that would never touch? I mean, okay. You're thinking too hard. All right, Tobin's right.
Bad thing?
No. All right, the TV technically is pushed a little bit in front of the whiteboard, so since it's vertical, is it going to touch this vertical over here? No. Okay, let's do one with a little bit more distance, like this front wall. What would be parallel with this whole front wall?
This one?
The back wall. Good. What's parallel to the top of your table? The ceiling or
the floor.
The floor. Good. Beautiful. Amazing. You guys did it.
Head.
I don't know if that's a surface. I like a flat surface. It's kind of a round head. Yeah. All right, here we go. Transversal. These ones now go kind of all together. So this one, the first three are more when we're dealing with lines in, these two specifically, are more in the three-dimensional space when we're dealing with it in real life. But I don't know, the rest of this chapter is not three-dimensional, so I don't really know why we teach this, but we do. I don't know. Okay, so here we go. We're going to start with transversal. This is where I'm going to use my highlighter as for a transversal today, so pick up your highlighter. Transversal has a prefix. It starts with trans. Okay, in math, we already had one word that started with that prefix. Yep, what was our trans property last time?
Transitive.
Transitive, good. So we had transitive. We have lots of other words in the English language that start with that, like transgender, transportation, transversal, I don't know. Lots of things. Probably more than what I'm thinking of, but those are the ones I got. Transitive. So what does it mean if you're going to transport somewhere? What does it mean that you're transporting? You're moving, you're traveling, you're switching. So transversal means to switch or to change. So when we talk about this transversal, it's what's going to intersect. It's creating kind of a pathway between two coplanar lines. I wasn't supposed to highlight that word at. Sorry. Got carried away with my highlighter. Okay, so it intersects two coplanar lines. So I'm going to draw two coplanar lines. Doesn't matter what those lines look like. They're just coplanar. They don't have to be parallel. Not today. And now I'm going to do the kind of that traveling. If I want this line to travel to this line fast, I can connect it with a transversal. So that is our transversal. All right, so as we take a look at the next part here, This one. Which one is going to be our transversal line? Is it kind of this top slanted, bottom slanted, or the one kind of going more vertical? Yeah, that one kind of going vertical. It's hitting both of the other lines. So this is our transversal. Okay, and we have two words here that we're going to be working with. We're going to work with interior and exterior. So interior, if you're an interior designer, where are the spaces that you are designing? Interior, where is that? What part of the house? Inside. No, that would be exterior. Okay, inside. Interior is inside. So when I look at inside of the two lines, I'm looking really like if I pinch those lines together, what would be squished together on the inside? So which numbers, which angles would be inside?
5, 4, 3, 6.
Yep, 3, 4, 5, 6. So if you'd like to shade that in with a color, if you're not using colors, don't shade this in with your pencil, because eventually we're going to shade in the other part, and that's just going to make it look like everything's shaded. If you're using colors, that's helpful. So this is our inside, our interior. I liked you better when you were up there. You didn't talk so much. Just kidding. I like your talking.
Thank you. I'm pretty good at it.
It's true. All right, then we have our exterior angles. So what does exterior mean? Outside. So our outside angles would be, if once I squish them, what's kind of left over on either of the walls. So that'd be our 1 and 2. But we have another outside, another wall. So we also have 7 and 8. Notice how I didn't put 6 and 7 together on purpose. So smart. So here's our exterior, and we also have an exterior down here also. I didn't though. I said 6 and 7. The dentist told me something the other day about 6, 7 weeks, and I went 6, 7, and she looked at me like I was stupid. I was like, you obviously don't have any kids. All right, consecutive interior angles. Now we're going to talk about pairs. We're going to be talking about two angles put together, and they're based on the relationship, based on kind of these words interior and exterior. Okay, so first one we have is consecutive interior angles. So first word I noticed there is interior. We've already talked about that. So where is it going to be? Where are these angles going to be located? Inside. But now we have this other word, consecutive. Consecutive. So if we have consecutive, a lot of times you hear that with sports or with weather. If you have consecutive wins, one right after the other, yeah. Or if it's consecutive days of rain, that means it's rained day after day after day. So in this case, though, consecutive is going to mean same side, like they're together, one after the other. They match. I don't want to use the word match, but just pretend I didn't use that. Okay, same side. Or I'm just going to use matching in a different one. Matching works better with one of the other ones. All right, so transversal here. So first thing I'm going to do is I'm going to highlight my transversal, because that's going to identify kind of that same side and what other sides we're looking at. Okay, so our transversal is the one that goes through both those lines. Now I'm doing interior angles. So I'm looking at these lines if I squish them together. So I'm looking somewhere inside. For the example today, we're going to just pick one to start with. So let's pick this bottom one here. Now, when I find the other pair, the one that matches this one, I want consecutive interior. And I want to go to the other line that this transversal cuts. So I'm not going to be at this intersection. I'm looking only at this intersection now. Do I want to be on the left side or the right side? Which way would be the inside of this line? To the left or to the right?
Left.
Left, good. Now I want consecutive, so I want same side as this transversal. So think of this as like a wall. Do I want to be above or below? I want the same side, so I'm going to be below. So these ones are kind of like they're inside and they're facing each other. They're in like two corners of one room facing each other inside. Do you know what's wild is that like ding sound is not my email. Somebody else's email that's so loud we can hear it in here. Wild. All right, here we go. Next one. Now this time we have alternate interior angles. So again, we have that word interior. Interior means inside. Now alternate, this is like when you are doing a zipper merge. Okay, when you merge and you're supposed to alternate how you go together, what does that mean? It kind of goes one and then the other and then one and then the other. So when you're zipper merging on the highway, you're supposed to kind of all go one turn after the other. One person from this lane, one person from this lane, one person from that lane, one person from the other lane. You're taking turns. Okay? So that is going to be our opposite sides. Okay, and again, we're locating those based on the transversal. So locating the transversal is always step number one. In some pictures, the transversal is very obvious, like these pictures. However, in some of the pictures on your homework, there's going to be more lines, and it might be a little bit more complex to figure out that transversal. So we have this transversal cutting through those lines. They touch both intersections, both other lines. I'm looking for alternate interior. So I'm looking inside. Okay, I'm going to just pick this one first. I just needed an inside angle to start with. Now there's two separate pairs of alternate interior. There's not just one. So on your homework today, when it asks you for alternate interior angles, there's two correct answers. You can do either one. Okay. So as I go to the other intersection, I'm going down here. I want inside. So should I go above or below?
Above.
Above. So I'm looking at these two angles are interior. And I want alternate opposite sides. So should I go to the left or to the right?
Right.
If I go right, this one was on the right. So I actually want to go on the left. I want to flip over that transversal line. So here it's kind of on the right. I want to now flip so it's on the left. I want alternate. Consecutive would be it would stay on the same side. Okay, we have two more words. You guys are crushing this. Alternate exterior. Alternate exterior. So again, we have that word alternate. But this time we're dealing with exterior. I used red for that one. Nope, I used brown. So based on our definitions before, alternate means what again? Opposite. But exterior means they're going to be outside. Okay, and again, we're looking at that transversal, that thing that's cutting it down. I always want to say down the middle. It's not the middle. You can obviously see it's not the middle. It just cuts both lines. Okay. So there's our transversal. This time we're looking at outside angles. So I'm going to start at this intersection. So take a look at the board for it quick. At this intersection, is exterior going to be kind of to the left or to the right? To the right. So you can pick either one to start with. Do you guys want to pick the top or the bottom?
Top.
Okay. Tobin says top. So here's an exterior angle. To find the alternate exterior, I need to go to the other line. I'm jumping from this intersection to this intersection. I have to move over by that transversal, travel down the transversal. So I need another exterior angle. So am I going to go left or right? Which way is my exterior on this side? Which way is the exterior and this to the left? Yep, outside because it was not squished together. But now I need it to alternate. This one was kind of above the transversal, so we're going to go below that transversal. Samaya, take out your notes. We're not done, bro. You were doing so good. This is like going to be the most important part of all of the chapter. All right, last one, we have corresponding. I'm going to use red for corresponding. This one, we don't have any of the words that we used before. If something corresponds, that means that it kind of goes together, it matches. So if I said, oops, Brecken, I told you you're sitting in the wrong table. You're in the same seat, but you're going to move to this table back here. Okay, Brecken is right here. If you guys don't know Brecken, this is Brecken. He's pretty cool. Okay, if I told him to move to this table but stay in the same seat, which table would he move? Which seat would he move to?
The one you're standing next to.
This one?
No, the other one.
This, yeah. This would match his seat. That's corresponding. If I told Brecken, hey, sorry, you're supposed to be sitting at this table, but sit at the same seat, which seat would he sit up here? The one Olive's in. Yep, good. So those are matching. So that's kind of what we're doing with corresponding is we're matching those parts. They're in the same position. So that's what we're going to highlight here, same position. At the other intersection. So again, we have that transversal. Highlight that transversal. Transversals are so important. Okay. I like this angle here. We're going to go with that one. I don't know. That one just looks nice. I like it. So if I start with this one, and I tell this angle, hey, sorry, you're at the wrong intersection. You need to move over. But stay in the same spot when you move over. Over here, where's the same spot going to be? Is it going to be above or below? Below, left or right?
Right.
Left. So when we look at this one with corresponding, are these interior or exterior angles? They're both. This one is what kind? Exterior. And this one is interior. When we do corresponding, you get one of each. Okay, corresponding angles, you always get one of each, one interior and one exterior.